Voyager 1 is dying. Not in a dramatic explosion, not in a collision. It's dying the way a candle dies, slowly, quietly, one flame at a time. Picture this, a spacecraft the size of a small car hurtling through absolute darkness at 61,000 kilometers per hour. No sun, no planets, no stars for trillions of kilometers. It has been flying for almost 50 years, and right now it is the farthest human-made object in existence, over 25 billion kilometers from Earth. So far that a radio signal takes more than 23 hours just to reach it. But here's what NASA isn't broadcasting. Voyager's final transmissions might contain the most important data it ever collected, and we're about to lose it forever. The question isn't just how far Voyager can go, it's what we'll miss when no one is listening anymore. At 25 billion kilometers from the Sun, solar panels are useless. Instead, Voyager carries 3 nuclear generators that convert heat from decaying plutonium-238 into electricity. When it launched in 1977, those generators produced 470 watts. That's all the energy Voyager ever had. Here's the problem. Plutonium-238 decays. Every year, Voyager loses roughly 4 watts of power. Over 5 decades, that loss has created a crisis. Engineers are now forced to make impossible choices. Which systems live, which systems die? Every watt they sacrifice is data lost forever. When Voyager launched, it carried 11 scientific instruments. The cameras were shut down in 1990 after taking the famous pale blue dot photograph. The software was deleted, the ground computers dismantled. Even if Voyager suddenly encountered something worth photographing, we couldn't see it. We blinded ourselves. By 2025, NASA shut down the cosmic ray subsystem. In 2026, the particle detector follows. That leaves just 2 instruments, the magnetometer and plasma wave subsystem. 2 instruments, measuring interstellar space. That's all that remains. But it's not just instruments dying. The heaters keeping Voyager's fuel lines from freezing are being shut off one by one. If the hydrazine propellant freezes, the spacecraft can't orient its antenna toward Earth. And if the antenna drifts even slightly, the signal is lost, permanently. There is no rescue mission, no second chance. NASA believes they can keep one instrument running into the 2030s, maybe until 2036. But after 50 years in space, every day is borrowed time. A frozen valve, a glitched computer, anything could end it tonight. Here's what nobody talks about. The data Voyager collects right now is irreplaceable. In 2012, Voyager 1 crossed the heliopause, the boundary where the Sun's influence ends and interstellar space begins. It became the first human object to leave our solar bubble entirely. And the data didn't match predictions. The interstellar medium was denser than expected. The magnetic field behaved strangely. Plasma waves appeared that shouldn't exist. Every day those instruments stay powered, we learn something new about a place we won't reach again for 50 years. Every watt that dies takes knowledge with it. When Voyager goes silent, we don't just lose a probe, we lose our only witness to interstellar space. Voyager is currently 165 times farther from the Sun than Earth. In late 2026, it reaches 1 light day away. A simple command and response takes 2 full days at the speed of light. Yet despite that distance, Voyager has barely left home. The Oort cloud, the true edge of our solar system, begins around 1,000 astronomical units away. Voyager is at 165. At its current speed, it won't reach the inner Oort cloud for another few hundred years. And the outer edge? That's 100,000 AU away. Voyager won't clear the Oort cloud for 30,000 years. 30,000 years ago, humans were painting caves. No agriculture, no cities, no writing. That's how long Voyager will spend just leaving our solar neighborhood. In about 40,000 years, Voyager will pass within 1.7 light-years of a red dwarf called Gliese 445. 1.7 light-years, over 16 trillion kilometers. It won't enter that star's system. It won't orbit anything. It will simply drift past, a cold, dead piece of metal, and continue into deeper darkness. Around 303,000 years from now, it passes another star. After that, predictions dissolve. Stellar motions become chaotic. Voyager's path becomes unpredictable. But here's the truth. Long before any of that happens, Voyager will already be dead. Sometime in the 2030s, Voyager's power will drop below operational levels. The transmitter fails. The computers freeze. The temperature plunges to near absolute zero. And then, Voyager enters a new phase, one that lasts incomprehensibly longer than anything before. Without power, without communication, it continues at 61,000 kilometers per hour. Nothing stops it. In the vacuum of space, there's no friction, no drag. It will drift for millions of years, hundreds of millions, billions. Scientists calculate it could take 10 to the 20 years, 100 million trillion years, before Voyager statistically collides with a star. A timescale so vast that the stars themselves will have burned out long before. Voyager will outlast the sun. It will outlast every star in our sky. It will outlast the Milky Way itself. Long after our galaxy merges with Andromeda, long after the last stars die, Voyager will still drift, carrying a golden record on its side. That record contains 115 images, greetings in 55 languages, 90 minutes of music and sounds of earth, wind, rain, birdsong, a mother's heartbeat. Designed by Carl Sagan's team in 1977, hoping something might find it. The odds are essentially zero. Voyager could travel longer than the age of the universe without encountering anything. The golden record will almost certainly never be played. But that was never the point. It was an act of defiant hope from a species that knew it was small, fragile, and alone, but decided to send a message anyway. Not a weapon, not a warning, a greeting. Music and mathematics and images of who we are, attached to a machine built to last 4 years that's lasted 50. Within this decade, possibly within years, the final transmission will arrive. Engineers will send one last command. 23 hours later, they'll wait for a response that never comes. The silence will be permanent. But Voyager won't stop. It will keep moving, keep drifting, carrying our voice into a future so distant that humanity itself will be nothing but a fossil footnote on a planet that no longer exists. And perhaps that's the most extraordinary thing about Voyager 1. Not how far it's gone, but that it will keep going long after we're the ones who are gone. The universe doesn't wait, but Voyager will.
What if I told you there's a world with a beating heart? A heart made of ice that's been alive for millions of years, slowly devouring everything around it. What if I told you this world has mountains taller than the Rockies, except they're made of water harder than steel, and some of them are floating like ships on a poisoned sea? What if I told you this world is snowing red organic molecules, the same building blocks that created life on Earth, and beneath its frozen surface, there might be an ocean, a liquid water ocean, 40 times farther from the sun than we are? And what if I told you we declared this world dead, unworthy? We erased it from our list of planets until NASA discovered we were catastrophically wrong. The 24th of August, 2006. The International Astronomical Union votes. After 76 years as the ninth planet, Pluto is demoted, reclassified as a dwarf planet. Children write letters begging NASA to reinstate it. Scientists protest. It feels like cosmic betrayal. But here's what nobody knew. A spacecraft was already on its way. NASA's New Horizons, launched 7 months before the demotion, was hurtling toward Pluto at 36,000 miles per hour, the fastest object ever launched, and it was about to reveal that Pluto was far more alive than anyone imagined. To the 14th of July, 2015, after 9 years and 3 billion miles, New Horizons screams past Pluto at 31,000 miles per hour. It has just hours to capture data before the tiny world disappears forever. The images arrive. Scientists stare in disbelief. There, dominating Pluto's surface, is a heart. A massive, gleaming, heart-shaped plane stretching 600 miles across. Perfectly smooth, no craters, just flawless ice shining in dim sunlight. They name it Sputnik Planitia. And the more they study it, the more impossible it becomes. That heart is made of nitrogen ice. But this isn't dead, frozen nitrogen. This ice is alive. It's convecting, churning, like a massive lava lamp, heated from below. Deep inside Pluto, radioactive elements are decaying, releasing heat. That heat rises through the nitrogen glacier, creating enormous convection cells. Hot nitrogen rises, spreads out, cools, then sinks back down. The entire plane is divided into polygonal cells, each 10 to 25 miles wide, constantly rotating. Each cycle lasts 500,000 years, which means Pluto's heart has been beating for millions of years. And it's still beating right now. But here's the eerie part. Sputnik Planitia is consuming Pluto. The nitrogen glacier is so massive, it's dragging Pluto's surface into itself. New Horizons spotted ancient craters being slowly swallowed, filled in, erased. The heart is devouring Pluto's scars. Now look at the edges. Mountains. Jagged peaks rising 11,000 feet, higher than the Rockies. And here's where physics breaks. Those mountains are made of water ice. But at negative 390 degrees Fahrenheit, water doesn't behave like ice. It behaves like bedrock. Water ice is harder than granite, stronger than concrete. These aren't fragile structures. They're fortresses, and some are floating. NASA scientists believe some water ice peaks are drifting across the nitrogen glacier like icebergs because nitrogen ice is slightly less dense than water ice. So these colossal mountains, miles high, made of ice harder than steel, are floating across Pluto's heart like ships on a toxic sea. Floating mountains. On a world we said was dead, now the snow. Pluto has an atmosphere incredibly thin, but it's there. Nitrogen, methane, carbon monoxide, and ultraviolet light from the distant sun is hitting methane molecules, breaking them apart and creating complex organic compounds called tholins. These tholins are reddish-brown, and they're constantly raining down like snow. But here's what makes it fascinating. Tholins are organic molecules, carbon-based, the same compounds that might have been precursors to life on early Earth. Pluto is being dusted in organic chemistry, the building blocks of biology, falling from the sky for billions of years. But the biggest mystery is underneath. Sputnik Planitia sits inside a massive impact crater. Billions of years ago, something enormous slammed into Pluto, creating this basin. Then, it filled with nitrogen ice. Here's the problem. That much ice is heavy. It should cause Pluto to reorient itself. The heavy side should migrate toward the equator. Pluto should tip over, but it didn't. Sputnik Planitia is still exactly where the impact happened. The heart is locked in place, permanently facing Pluto's largest moon, Charon. Why? The only explanation is terrifying.